What do you think quantum mechanics is? You might say, quantum mechanics? Oh, it has nothing to do with me. If you did think something like this, close your eyes for a minute and just imagine what would happen if none of the three things I'm about to mention didn't exist in this world. Computers and smartphones, the sun, and the process of breathing. Just think about what the world would be like. I mean, we definitely wouldn't be alive, right? Especially the last two. We can't live without them, can we? Now, if I tell you that all of these are made possible by quantum mechanics, does that spark some interest? It's true. The three things I just mentioned are all related to quantum mechanics, and they exist because of the laws of quantum physics. Hey there, I'm Chibi, and in this video, we'll take a little trip to the fascinating world of quantum mechanics and contribute to humanity's journey to understand the essence of the world. I hope you'll get a new view about quantum mechanics at the end of the video. So, what are you waiting for? Let's get started. To get straight to the point, in one word, quantum mechanics is a study of movements in the incredibly small part of our world. Humans used to think that atoms were the smallest objects in the world. However, as science developed, it was discovered that atoms were made up of protons and neutrons, which are made by something called quarks. These substances that are at a subatomic level are called quantum. If we think of a quantum as the size of an apple, an atom will be as big as the Earth, and that's how small they are. So basically, quantum mechanics is a study that deals with the dynamics and movements of this quantum world. What's so interesting about that? Well, it's the rules in this world that are amazing. The rules in the world of quantum are 180 degrees different from the rules in our world. So how are they different? In this video, I will introduce three things: wave-particle duality, the property of superposition, and the property of quantum collapse. You might be going like, what in the world are you talking about? But hear me out. I will explain everything in detail through an experiment called the double slit experiment. The double slit experiment is a famous and very exciting experiment that helped to lay the foundation for quantum mechanics. For starters, researchers prepared a screen and a plate with a narrow slit, and then applied a light source to it. As expected, the light passed through the slit and formed a single line in the wall. Next, the researchers made two slits in the plate and applied the light source. Now what do you think happened this time? The light passed through the slits and two lines were formed on the screen. It is what most people expect to see. However, in reality, not two but multiple lines were formed on the screen. Why? Well, photons, which is a type of quantum, are the smallest unit that makes up light. Until now, researchers had thought that photons were particles. However, this experiment revealed that photons were both particles and waves. Therefore, the reason why multiple lines appeared on the wall was due to the interference between the photons, which are waves too. To make it easier to understand, imagine yourself sticking your fingers into the water when you're taking a bath. Waves propagate in both directions from that point, right? Interfering with each other, they continue spreading more and more. This is what happened in the experiment when multiple lines appeared on the screen. So the photons spread out just like how the waves spread out in the water. My point is that quantum, such as photons, have the properties of both particles and waves. This is what we call the wave-particle duality, which I mentioned earlier in the introduction. The wave-particle duality of quantum is extremely important for semiconductor devices like transistors and computers and smartphones. These devices control electrons and process information. Transistors can amplify and switch electronic signals, making them significant for digital information processing. They rely on the wave-like behavior of particles, like electrons in semiconductors. This behavior affects energy and motion, allowing very precise control of electric currents. So to sum it all up, wave-particle duality is the reason why computers and smartphones exist. Now it'll get even more interesting from here, so brace yourself. For the next experiment, researchers fired photons one by one towards the slits instead of applying the light source directly. Since the photons were being fired one by one, there's no way they would interfere with each other like last time, right? Therefore, researchers expected to see only two lines on the wall. However, what they actually saw were multiple lines again. Now why is that? Quantum particles have this crazy property of being able to take on multiple states at the same time. It's like a person is sitting in a chair and lying in bed at the same time, or being at the top and bottom of a mountain at the same time. It's obviously impossible in our everyday world, but in the quantum world, it's possible. This property that quantum has, where they are not fixed and can exist in multiple places at the same time, is called superposition. Since photons are also quantum, they naturally have this property. This means that even though the photons were flying one by one, they were still able to interfere with each other because they were in multiple places at the same time. I know, it's insane. Finally, let me introduce the quantum collapse property, which I personally think is the most interesting one. Researchers who were still not convinced decided to record the photons that passed through the slits until they reached the screen. Now, what do you think happened? Surprisingly, only 2 lines appeared on the screen instead of multiple lines this time. But when they stopped recording, multiple lines appeared on the wall again. Very surprising, right? After all, it was just a matter of recording or not recording the photons. Let me explain. As I mentioned earlier, quantum has the superposition property, where they can exist in multiple places at the same time. However, the moment a human being observes them in any way, they collapse to a single location. Since recording the photon is a way of observing, the photons that were recorded returned to their fixed state. And then when humans stopped observing, the photons returned to their uncertain state again. This process of quantum particles returning to a single location due to human observation is called collapse. These properties of superposition and quantum collapse have made countless things possible. One of the most essential ones is breathing. When humans breathe, the energy from inhaled oxygen is stored in a protein called ATP. The process of creating ATP involves a very complicated process, and one of them is the electron transport chain. In this step, the goal is to activate the ATP synthase, which is kind of like a factory of producing ATP. To activate the ATP synthase, a decent amount of energy is required. This energy is obtained by pumping out hydrogen ions by each enzyme in something called the respiratory chain. After pumping out the hydrogen ions, the enzyme captures the energy that was left by the ions and passes it on and on to the next enzyme, creating a chain-like process. However, there's a problem here. The distances between each enzyme in the respiratory chain is too big, making it difficult for electrons to travel from one enzyme to another. Here's where quantum mechanics comes. As I mentioned earlier, in quantum mechanics, there's this property called the superposition property. And this property allows particles to probabilistically transport from one side of a wall to the other side, as if there's a tunnel. This is known as the tunnel effect. Scientists say that electrons use this property to jump from one enzyme to another, making the electron transport chain possible. This is why quantum mechanics has played a huge role in the process of breathing. While this theory is one of the strongest, scientists are not yet 100% sure that this is correct. As you can see, quantum mechanics has really broken the mold. For example, for a long time, people thought that every physical phenomenon could be predicted from its physical laws. However, it was different in the quantum world. And this is because quantum exists in multiple places, and so they sometimes go forward, sometimes left, and sometimes to a completely different direction. Therefore, in this world, the only thing humans can do is probabilistic predictions, where they guess the probability of where the quantum particle is at. Quantum mechanics also turned around the common sense that humans' intentions do not affect the science world. Observations come from humans' will to see what the quantum world looks like. In the double-slit experiment, it was revealed that humans' observations affect quantum states. In other words, it was revealed that humans' intentions can affect the quantum world. Why can humans' minds have such a big impact on the world of quantum? Why is the rule so different in this world? And what really is this world in the first place? Here's Einstein's response to these questions. God does not play dice. Einstein disagreed with the idea that humans can only make probabilistic predictions on something, and the idea that humans' intentions affect the quantum world. He thinks there is something that we haven't discovered yet. Unfortunately, humans haven't discovered what that something is at this point. However, this might change depending on your actions. So, that was the basics of quantum mechanics. Let me go over with you a few things that I said. First of all, the wave-particle duality means that quantum objects have both particle and wave-like properties. And the property of superposition means that a quantum object can exist in multiple places at the same time. Finally, quantum collapse refers to the process where a quantum object that exists in various places returns to one location due to human observation. It's truly amazing and mysterious, isn't it? When I first heard about the property of superposition or quantum collapse, I was like, huh? What is that? This is totally crazy. Of course, this is only the very basics of quantum mechanics. But if this video can be a catalyst for people to become interested in quantum mechanics, I'll be really happy. Thank you so much for watching. Now, let us return to our everyday lives.